Hi everyone, I am Dr. Surjit Singh. In this video on Python via examples, I'll talk about the searching techniques. Let us begin. In this session, we will discuss about searching of a key in a list and about advantage of sorting in searching. We can also find the position of the key in the list. We learn about the while loop of Python. We shall also discuss about the binary search in finding a key in a list and about finding the root of an equation. We'll also learn about hashing. One of the important operation in data processing is about searching of an item in a list. We are given a list of scores and a key value that we want to find in the list. We shall start with the linear search. To begin with, we are not sure about the presence of 8 in the list, so we start with found equal to false and start searching the items in the list one by one. Starting value of S is 7 and we compare it with the key, but 7 is not equal to key. In the next iterations, S is 5 and then 4. When S becomes 8, it equals the key value. So we mark found to be true. There is no use going further in the loop. So we break the loop. Now that found is true, we print the message. However, if key is 6, loop will have to scan all the items, but the if statement will remain false. Found will not become true and the loop ends. If found is now false and we print the message about the missing key. This searching method is called linear search because the search time is proportional to the length n of the list. An improvement is possible if we use the sorted list. Once again, we start searching from the beginning of the list. We stop going ahead if S becomes greater than key, and therefore we do not have to scan up to the end of the list. For this, we split the if statement into two ifs as shown. If we also want the position of the key, we replace found equal to false by key position equal to -1. Enumerate scores gives the tuple pos and s in each iteration. If s is equal to key, we save its position. At the end of the loop, if key position is no longer -1, we print the position of the key. If the key value occurs more than once in the list, we print its first occurrence. On a sorted list, a faster searching method is possible that is called the binary search. Consider an example in which we want to search for a word in a dictionary of 1000 pages. We'll never start looking for the word from the first page onwards because this sequential search will be a sheer wastage of time. We inspect the middle page of the dictionary and decide which side has the word. This reduces the search pages to 500 in one go and to 250 in another go. This further goes to 125, 64, 32, 16, 8, 4, 2 and to one page in just 10 bisections of 1000. Mathematically, we say that log of 1000 to the base 2 is 10. The binary search is not linear but logarithmic, which is also called log linear. It is clearly very fast because instead of 1000 searches, we just need 10 searches. This becomes possible because the words of the dictionary are sorted alphabetically. No doubt that sorting takes time, but we sort the words once in the dictionary and use it many times every day. Now consider a sorted list of 13 numbers and we want to find the position of the key, that is 16. In the beginning, we assume the key position to be -1. We set the left fence at the beginning and the right fence at the end of the list. Numbers between these two fences constitute the range in which we are searching for the key. Gradually, we shall narrow down the range between them. While loop of Python has a Boolean expression after while. Loop iterations continue as long as the Boolean expression is true. When the Boolean expression becomes false, we come out of the loop. We shall continue in the loop as long as left fence is less than or equal to the right fence. We find the integer in the middle of left and right. This divides the list into three parts. If item at mid is found to be equal to the key, then the job is done. We will then save the mid position as the key position and break the loop, as there will be no need for any further checking. But this is not so in our case. 13 is less than key value of 16, so key must be within the right partition, and we move the left fence to mid plus 1. In the next iteration, mid is the middle integer of 7 and 12, which is 9, and the partition splits as shown. This time, the item at mid, that is 18, is greater than the key, so key has to be in the left partition. Therefore, we move the right fence to mid minus 1. Left is still less than right. In the next iteration, mid of left and right is 7 and the range splits as shown. This time, value at mid is less than key, so new left is mid plus 1 and the range is of one item. New mid also becomes 8 and the value at mid is equal to key. We save it as the key pose, break the loop and print it. If key is 6, this is the first iteration. Key is in the left partition. Now mid becomes 2. 6 is on the right side of 5, so new mid becomes 4. New right becomes 3, so mid also becomes 3. Item at mid is greater than key, so right becomes 2. Now that left is greater than right, loop terminates without modifying the initial value of key pos, so we get the output pos as -1, which indicates that key is not present in the list. Another example of binary search is in finding a root of this equation. At x is equal to 0, function is -1, while at x is equal to 1, function is +1. We can find these values easily by inspection, or we can calculate them at this stage. A polynomial function is always a continuous function. It must become 0 somewhere between x is equal to 0 and x equal to 1. So these values of x become the two fences for the root. The root is the value of x where function is 0. Let us start writing the Python program for this. In the beginning, left is 0 and right is 1, while the function is -1 at x is equal to 0 and it is +1 at x equal to 1. In a loop, we shall narrow down the gap between right and left fences. For finding the root correct up to 2 decimal places, we repeat iterations as long as the gap between right and left fences is greater than 0.01. First time, x at mid of left and right is 0.5. It divides the range into two halves. We use the mid value of x to calculate function at it and print them. Function is negative at both left fence and x, so the function is not 0 in the left partition. Therefore, root is present in the right partition and we move the left fence from 0 to 0.5. Values of the function at 0 and 0.5 are both negative. We can make the sign comparison easily because if two numbers have same sign, their product is positive, which becomes the check in the if statement. If the product of function values at left and x is greater than 0, left becomes equal to x and the function at left becomes equal to fx. Gap between left and right is now 0.5, but it is still very large, so we perform another iteration of the loop to find the new value of x and the function at this new midpoint. Midpoint of left and right is now 0.75, which is new x. This time function values at left and x have opposite signs, which we confirm by finding their product, which is negative this time. In this case, the root is present in the left partition, therefore the right fence must move to x and the gap between right and left further narrows down. We execute the else part of the program when function values at left and x have opposite signs, that is when their product is negative. In the next few iterations, x and fx values are as shown here. At this stage, gap between right and left is less than 0.01, so value of x is now correct to 2 decimal places and it becomes the required root. We may also note that value of the function at this point is practically 0. The while loop ends at this stage. If we require the root correct to 3 decimal places, we only have to reduce the tolerance to 0.001. Each decimal place requires about 3 more iterations of the loop. If speed of searching is the aim, hashing is the fastest. In this, we make a list of possible keys and assign a memory location to each one of them. We maintain a table to reach the appropriate memory in a single step to determine if the key is present in the memory or not. But the disadvantage of this method is that there is a wastage of memory, especially if most of the key values are not present at any given time. Another disadvantage of this technique is that duplicate keys are not allowed in this method. In this session, we discussed about searching of a key in a list and about advantage of sorting in searching. We learned about the while loop of Python. We also learned about the binary search in a list and in finding the root of an equation. We also talked about introduction to hashing. I hope you liked the video. Please feel free to ask for further clarifications on my email address given below. Please stay tuned for more.